Hi everyone, I'm Chris and let's talk a bit about thermal throttling. I recently ran into this problem because of this laptop. This is a Dell Precision 3551. It's a pretty good machine. I've had it for about 4.5–5 years and I actually like it. However, lately it started to, so to speak, act up, slowing down. I couldn't render with it like I used to. Well, let's add that the hot weather has also arrived. But the standard maintenance procedure that is typically followed in these specific cases, where you thoroughly clean out the cooling fan unit and carefully replace the old thermal pastes, well, that has all been completed already. In fact, I even went as far as to inspect the individual mounting tabs, which are responsible for securing the primary mounting screws directly to the bottom clamp of the motherboard assembly. I even bent those up a little bit more than before, so that when I finally screw it back on, it presses down on both the video card and the processor equally, but with a relatively greater amount of force. However, I really should take a moment to mention here that you should never lift this specific tab too much. This is because the uneven pressure or even just too much force can easily crack or permanently damage sensitive components such as the video card or the processor die. They call it the die, the edge of the silicon or the silicon cube, and then you'll end up with a very expensive paperweight. Unless you ask someone to replace the processor, say at a BGA rework station. So here is exactly what I did to the machine. I carefully repasted the processor, thoroughly cleaned out the fan, and after all that, the whole thing only improved by about 2 or 3 degrees, which, to be honest, I wouldn't exactly call a very good result at all. You see, these specific machines have a well-known characteristic that is commonly referred to as thermal throttling. The point of this is that when the temperature reaches 96 or 97 degrees Celsius, at that exact moment an internal protection mechanism automatically activates, which reduces its own clock speed. It needs to reduce its own clock speed because then the temperature also starts to gradually drop back down. Obviously, this involves a loss of performance, and it can even lose 40 or 50% of performance this way from the processor's operation. There's an automatic feature where certain processors can even turn off cores, but I won't go into that now. This is the current situation, and we're going to try to make this laptop usable again, even in this intense heat. It's overheated many times in its life, but I was actually wondering why Dell doesn't include an asbestos glove, at least when they sell these machines, but there was nothing like that in the box. But you see, yes, in this state, it's capable of burning through its processor faster than your salary. So we're going to try a specific option, a particular feature that generally at the moment Dell but no laptop manufacturer likes, namely deliberately messing around with the processor's clock speeds. We, however, will do just that, and the point will be that most likely all kinds of settings are locked right now in the internal BIOS. We're going to try to unlock this now, which means to release it. What we are going to need to modify, since we're talking about undervolting, is the core voltage of the processor, which we will then reduce. As for the current limit and the maximum level set by the VRMs, the voltage regulator system, we'll keep those settings exactly as they are for now. However, we'll be carefully lowering and optimizing the processor's V-core voltages, the processor's cache voltage, and the integrated graphics card's voltage as well. Then we'll compare how well and how successful this so-called undervolt procedure actually turned out to be in terms of performance. The first thing that's very important for everyone to be fully aware of is that this specific trick involves a direct modification within the system BIOS settings. You'll need a piece of software for this called ThrottleStop. That's what I'll be using. It's a pretty good application from Tech Power Up, and we'll see exactly how we get on with it as we move forward. I've already looked into it a little bit. I haven't gone all the way through yet, but let's dive in right now. So the first and most critical thing you need to consider is that your BIOS should always be kept fully up to date to ensure your system runs smoothly. We can easily do this by downloading the latest and most compatible BIOS version available for your model. In this case, we are going to download the update directly from the official Dell support website, and then we will carefully proceed to install it on your computer. So first go to support, then drivers and downloads. And it says to close this current window right here and identify your product. This specific model is a Precision. It is a Precision 3551 workstation laptop. Yes, this is it. So we will decline that for the time being. Next, go ahead and select drivers, and we'll indicate that we specifically require the BIOS. And here we see that for the 3551, the latitude 5411, 5511, here's the system BIOS, which is 2026, July 6th, and we'll just download it. Oh, and then we can see right here that the current version and the new version are virtually identical in every single way, or pas sont trop. So a few specific things haven't updated yet, but however, it is exactly the same system BIOS currently on it. Okay, so what we are going to do right now is go ahead and click Update. At this point, it nicely loads the firmware data into a so-called option ROM or a flash memory, depending on the architecture of the Intel ME management engine. After that, please note that it will automatically install the BIOS during the restart process. Let's just simply click on the restart button. We'll wait until the BIOS is installed. Successful BIOS update. Okay, so now that the BIOS is updated to the latest version, we can rest easy because we don't have to worry anymore about a future BIOS update overwriting our carefully configured current settings. Which, by the way, isn't certain to happen at all, but it's better to be safe than sorry because you never know. But this can be turned off. It's called Capsule Update. I'll show you how to turn it off in the BIOS. The point is, the reason we had to install the latest BIOS is so that if for some reason you wanted to update it anyway, you wouldn't have to perform the same operation all over again. So that's exactly the point. It's always worth starting with the latest BIOS because it's usually always better and more optimized. So the next logical step in our process now is to take a very close look at the laptop's current thermal profile to see how it handles heat. We can easily accomplish this by opening up the comprehensive Hardware Info 64 application, navigating to the Sensors tab, and then starting a demanding system stress test to push the components to their absolute limits. We will not update at this particular time, thank you. So let's commence a stress test. The sensors. Along with the sensors. So conducting a stress test and heavy load analysis with the SSE instruction set is working perfectly fine. And now let us go ahead and get everything started. Let's see how. Yes, this is actually quite high because not even 10 full seconds have passed yet, but almost all of the CPU cores are already sitting at 99 degrees. You can clearly see the situation here, and the remaining distance from TJ max, which is the maximum thermal limit, is only 1 or 2 degrees Celsius at most. So it's constantly throttling. Well, now, as you can clearly see, it's averaging around 3.3 gigahertz. But that's not even the biggest problem. It's the fact that the processor is constantly sitting at around 100 degrees Celsius. And if, say, the graphics card also wants to do something, because this has a Quadro P 520, and so we need to get ahead of this problem right now. So the plan is to undervolt, which essentially means we'll carefully lower the processor voltage, the turbo clock speed, and the maximum power the processor package can consume during operation. We can modify this, so I'll just shut this down now so it doesn't torture my laptop any further. I'd still like to use it for another year or two. So there is actually an application called ThrottleStop. And once we go ahead and launch it, yes, there's a message here saying that everyone should use it at their own risk. We're not using it to overclock the machine, but to underclock it because it's overheating. I recommend this to many people's attention. And you see the application already displays quite a lot of information here. This includes details such as the core temperatures, the maximum temperature reached during the most recent run, and which specific monitoring options are currently enabled. But it's constantly in hot and proc hot mode, so basically this processor is boiling. So once you click on the 5VR button, you will notice that practically no settings can be modified here. This includes both the offset voltage and the ICC max values, but then again, we don't even want to touch those. That 100 amps there is plenty. So you see, we actually cannot modify this at all. And that's because this option is locked in our BIOS. We can't unlock it visually, but we can by editing the settings. So the next thing is that we need to find those positions in the BIOS, or rather in the BIOS update file that was used to update the BIOS, to see where those positions are in it. So since the latest BIOS is on the machine, we'll need the positions belonging to the latest BIOS. So what we are going to do right now is shut this entire process down immediately. And then we will take a closer look at something called BIOSUtilities. This folder, by the way, this BIOS mod folder, you'll find it on my GitHub. The link to my GitHub is in the video description. This is my personal public GitHub. All different kinds of tech or programming or software development will be in there, and whatever is open source by me, I'll keep it. Anyone is free to use it. So BIOSUtilities. This is a Python project. I pulled this from GitHub too. It's basically a BIOS unpacker. So for example, Dell also has these PFS type compressed files, which you saw earlier, that updated the BIOS, that did the capsule update. It unpacks that. First, we need to go ahead and open up a new command prompt window, which is also commonly known as the command line interface. And from there, we will carefully browse our way through the directories until we reach the specific BIOS mode apps folder located on our system. And the essential integrated BIOSUtilities, naturally. Oh, before I forget. If you look inside the BIOS mode folder, you will see a prerequisites folder. You should install 7-zip, Python, and also make sure to unpack the Visual C runtime all in one compressed folder. This is necessary because a wide variety of different system libraries need to be installed on your machine. It's not just for these programs, but it might be needed for future programs as well. So run as administrator, install, and you're done. Well, once you're done with that, we're going to create a Python environment now. We need to create this because I'm obviously speaking from my own experience now. I absolutely don't like having all various sorts of Python libraries installed on my local machine, no matter what programs I use. I like it when every Python library is strictly in its own virtual environment, which belongs to the system in its own folder. This means that Python doesn't load its own modules from the system Python, which is installed at the system level, but from what's in the virtual environment, and that's what we'll use. So, the first thing is to create the venv that is python-m, which means module venv, and where do we want to create it? In the same directory under venv. In this case, Python creates a virtual environment where it will put its own little packages. Once that's done, we need to activate it, because that's what we want to work in. We can accomplish this task with the virtual environment scripts and the activate command. And as you can see, right now at this moment, that's not exactly what I wanted. As you can clearly see on the screen, the virtual environment is now successfully activated. The next step we must take is that we have to install the various Python packages and dependencies that are currently listed inside the requirements.txt file for our project setup. That's necessary because these are the dependencies, the package dependencies, so that this application can run, so we can unpack the BIOS. So python-m module pip. We'll use the pip module, specifically install -r and requirements.txt. This will nicely install all the dependencies we'll need to run main. And we're done. Well, and now it's time to execute and run the main.py file, which is the core script of the application. The program immediately asks us to provide the full directory path to where our packed BIOS is located. Now I've copied the packed BIOS. Sorry. I've already copied my downloaded BIOS here, specifically the Dell exe file. So this is what we need to provide as the source path to be unpacked. The extracted BIOS, however, is the folder where we need the unpacked files. But before we can actually have it unpack the files for us, the 7-zip application that you have already installed on your computer, which is the archiver tool, that specifically needs to be added to your system environment variables first. Which essentially means that if you go ahead and press the Windows key and then type out edit the system environment variables in the Hungarian operating system, the correct setting will pop up on your screen. For me, what I usually do is search for edit system environment, or rather, edit the system environment variables. And then I'll go ahead by clicking the environment variables button, and finally selecting the path option. Go ahead and double click on that icon, and I've already added 7-zip to the list, but you can add it yourself by clicking on the new button, then browse, and then you nicely select your local disk C drive, navigating through program files, and then finally the 7-zip folder. Click OK, and then it's there. This will be needed because the Python script calls an application from 7-zip that helps unpack the archive. Click OK, OK. However, in this case, if this was modified and wasn't already set, it won't work, because we need to restart the terminal console for these new environment variable settings to take effect. So the easiest way to do this is to carefully copy this text all the way up to the arrow, but make sure you don't include the arrow itself. Now right-click, find the drop-down arrow, select the command prompt, and type cd, which stands for the change directory command, and then we can go back here. You can go ahead and close this now, it won't be needed. And you can verify that it is working by simply typing in the command 7z. If typing 7z displays all of this detailed help information. If this help menu from the 7-zip application appears, then we're on the right track. So now we need to go back into the venv, the virtual environment, scripts activate. And from here on, python main.py, and there we go. Now the next important thing to keep in mind is that since the software's current working directory is set to the BIOSUtilities folder, we actually need to navigate back up 1 and then 2 levels in the file structure to reach the specific folder where the downloaded BIOS is stored. This is necessary because the program is explicitly asking us for the exact file path that we need to use. So we will go back 1 level, then 2 levels, locate the BIOS directory, and finally select the downloaded BIOS file from there. This contains the executable, which is the file we want to extract. Back once more, and now we'll specify where the extracted BIOS should go, and it'll extract it for us. There it is. We press enter, we type in exit, done. From here on, nothing else is needed. In the extracted BIOS directory, we now have the extracted executable, the firmware, and most importantly, this file. The system BIOS with BIOS guard. We're actually going to be needing this later. We need the values from it. So we go back up the directory levels to BIOS mod, then applications, and then the UEFITool. By utilizing the specialized UEFITool, we can carefully look into exactly what kind of memory addresses or specific mappings are contained within this extracted file. So what you need to do is open this system BIOS with guard, which I demonstrated earlier using the UEFITool. Then navigate to the action menu, select search, and manually type the phrase overclocking lock into the search bar provided. And we see that it's in the PE32 image. We're not just going to disable this, but 3 functions in total. So 3, but this shows us the location. If all 3 of these specific components were not located together in the same place, we would obviously be forced to search much further and across other areas to find them. So we should proceed to extract these files exactly as they are right now. After that is done, we will save this into our designated BIOS mod work directory, naming the file BIOS Setup. Once we're done with that, we'll just close it up. Next, we need the IFRExtractor. This program can nicely unpack for us that this program can decompress and extract the binary PE file into human-readable file formats, and show those structural elements in the BIOS that are currently concealed at the UI level. So the user interface doesn't show them, but they are hidden inside. Extract meaning unpacking, and then you see BIOS Setup, IFR, saving. We save it. We can close this now. It's no longer needed. We go back 1 directory to the work dir, and there you will see the BIOS Setup IFR. Right-click. We open it with Notepad. Unfortunately, this is all we have right now. Good. And the first thing we'll search for, Control F search, is the overclocking lock. You see it found it, and obviously there's only 1 of these, no more. Its var offset var name is 0xDA1. So let's write down that the overclocking lock is 0xDA and disabled, meaning we want to turn the lock off. It will need to be set to a value of 0x0. So I'm just going to type this into my phone now. So 0xDA is the overclocking lock. Alright, the next thing that we need, which we need again, is the CFG lock. Oops, sorry, I typed it in the wrong place. This is the CFG lock. The CFG lock is actually the overclocking itself. The info isn't exact, but I think it unlocks it so that Well, for this function to be available as an unlock, you first have to unlock the CFG lock. So let's write down the CFG lock as a value of 0x3e. And then we're done with that too. The next thing we still need is the BIOS lock. The BIOS lock is, if you please, 0x17. This is needed so that if you want to modify these data from within Windows, then, well, it leaves the write protect leg of the SPI memory where the BIOS is open during runtime, so before the operating system loads, it doesn't close it. So you'll be able to edit it just the same using the RU application. So the BIOS lock it's 0x17. The BIOS lock is 0x17. So now that we have these pieces of information and functions, nothing else is needed. At this point, we can go ahead and safely close out of this application, and you will see that there is a specific directory here called extract USB. If you look inside of this folder, there is a zip file waiting for us in here. To begin the process, you should copy all the individual contents of this zip file, or alternatively, you can copy them directly to the root of a formatted FAT32 USB flash drive, much like the specific one I am demonstrating for you right here in this example. I'll just go ahead and copy it over one more time. Okay. So what you do is drag the EFI folder over here. Then once that's finished, we will boot directly from it and we'll run the RU.EFI file to start the process. So the point is that the boot x64 EFI, which loads first during UEFI initialization, is a shell. It's basically a command line. It's there so that we can run the RU.EFI. So let's restart the machine. I am now going to execute this using the command prompt interface. Shutdown. So then the very next step in our plan is to carefully and nicely select the UEFI USB option from the menu. Once you have done that, we need to wait for the shell to finish loading completely. After it loads, we will manually type in the command ru.efi. Once you see this command on your screen, simply press the enter key, and then you will see James Wang's specialized software appears right before us. So what we are going to do here is actually quite simple. It is nothing other than systematically changing every single one of the values listed from 1 down to 0. To begin the process, we press Alt-C, and then we successfully enter into the settings of the UEFI variable. So now we'll start manually typing in the command for CPU setup to proceed. However, we don't need this CPU setup, but the next one. So we type CPU setup once more. And this is it. This CPU setup is the one we'll need. In this, we need to modify 2 values. The value we need is the overclocking configuration lock, which is set to the hex value 0xDA. So this value, meaning the lock function, is turned on. We turn it off with a 0. Then we just press enter. The next function to turn off is the CFG lock at 0x3e. Here it is. And as you can see, we are at 0x3e here too. We type in 0, enter. And what's very important, now that these specific values are modified, if we scroll away right now, the settings will be lost immediately. So we press Ctrl W, and with that, we've saved it to the memory, specifically the SPI non-volatile memory. And now we just keep pressing page down repeatedly until we finally find a setting called PCH Setup. That's it. So you can see down here PCH Setup. In this one, however, we need to modify the BIOS lock, which is at 0x17, that is this parameter, 0x17. We change this to 0. We press Ctrl W, enter. And now we have nothing else to do, everything is written down. First, we press the Alt and Q keys simultaneously, which exits the current program, and then we type the word reset into the command line, followed by pressing enter. Now the machine will shut itself down completely, then turn back on again, and then I'll show you the next step. You can safely pull out the USB stick now. It won't be needed anymore. Alright, so the computer has restarted. We are opening up the ThrottleStop application once again, and now it should finally allow us to use our settings. In the same way, everything is currently boiling inside the machine with a hot processor and hot performance, which is okay. So let's click on FIVR, and as you can see, there is no locked function shown under it anymore. Before we start to play with this, I say let's go ahead and do something like running a quick TS bench test. And a standard baseline 8 thread, 128 megabyte bench. We'll run it now to see the value it brings. And then after that, this is all before overclocking, and then this is also before the undervolt. And we'll check it again after the undervolt too. So you see absolutely everything here is unfortunately getting very, very hot. 3.3 gigahertz is the ceiling almost. Its turbo is worth nothing like this. Okay, so with 8 threads, the final result we obtained was 27.826. And so now what we are going to do next in this process is nicely set the specific performance data that is good for us and that we really need. Let us go ahead and start by looking at the CPU core. Definitely unlock adjustable voltage, and this goes nicely down to minus 120. In this case, right, this is an i5 10300H processor. This minus 120 millivolt voltage is still well within the limit, which is also perfectly fine. We won't touch the ACMEX, that is the amperage. We'll leave the VRMs alone. We're going to modify the CPU cache now as well. That one, however, to minus 80 millivolts. That's about normal. Minus 80. We won't touch the system agent. We can also decrease the offset of the Intel GPU by a small amount if I unlock it. Say to about 25. The iGPU on slice as well, say to about 25. This effectively ensures that it is prevented from emitting extra heat while maintaining the same performance level. So let's go ahead and apply these changes to our current setup, and we can also safely turn on the specific feature known as save voltages immediately. However, one crucial detail that I completely overlooked just a moment ago is the configuration for the turbo ratio limits. I think it would be a very good idea to lower these values just a little bit for now. I really think we should start by setting these individual values to 40, then 38, followed by 37, and finally 36 respectively. This is important because we won't be able to use the processor's maximum turbo frequency anyway. It's just not possible with this kind of cooling. I don't even think it would work if you put a real laptop cooler under it, because that cooling medium is simply unable to handle it. So due to the nature of this specific design, it simply can't provide the rapid heat dissipation we need for this setup. Anyway, let's carefully apply these settings now. So we are looking at the values of 40, 38, 37, and 36. And what we are going to do next in this demonstration is we'll hit OK. The TPL, we're also going to modify the maximum voltage it can take, because with the MSR, it's also very important that the system doesn't overload itself in any way. So let's say 4 seconds, 5 seconds for the maximum turbo time limit. The long power limit can easily be around 30. Let's try it with 35 watts. We can set the short power to the same or even a bit higher. Let's make it 37. It's going to fundamentally transform a wide variety of different system settings. Let's turn on Sync MMIO and then apply these changes to the configuration. All right. And from now on, once we are completely prepared to proceed, let's hit turn on. And from this point forward, our processor clock speed and turbo settings are fully operational and currently active. So 65, 63, and 65. Okay. Now that previous result was 27,826. And then let's just see exactly how much the temperature goes up and how much faster it might potentially be in this case. As you can see, the temperature doesn't jump up so much immediately anymore. So this is very, very good. Wow. And since there's no throttling, we easily gained a full 5 seconds. So that's precisely the point we are making here. Even if the turbo is good in the long run, or short run, sorry, for that little time the processor spends overheating and cooling back down, it effectively drains energy away from all the other processes. That's why I'm saying that undervolting is a pretty good thing. And now let's look at a stress test, so you don't say, oh, well, of course, because that was just a TS bench calculation, it's not definitive. Okay, now let's go ahead and check out the stress test right now. So let's just leave this window open for now. We can go ahead and close this other one, and what we specifically need to open up is UEFITool. And now we'll see what the machine does under undervolting. So back to the sensors. As you can see, the temperature is currently around 75, 70, 68, 69. That's because the automatic fan control is obviously applied by its own dedicated internal controller. Because at 60 degrees, such fast fan movement isn't justified for these yet. Okay, so the sensors were in, and then stress test. All right, let's see what the final results were. This is the integer SSE test CPU, and this is our current column. This is what to watch, and we'll let it run for at least a minute. I don't know if it's going to throttle. It's possible in the first 10 seconds, but no, the fan is barely even running in the machine. True, 86 degrees, 87 degrees, but it still hasn't kicked in. This is 91 degrees. We'll check in a moment if there's any throttling. Oops. There's no proc hot or throttling yet, and we're at 88 degrees. And since the TS bench finished sooner, it means our performance is at its maximum, so our laptop is faster at maximum performance with undervolting than with turbo boost. This isn't a coincidence, because if it exceeds a certain temperature, the processor throttles so much. So imagine this as a graph. So the internal temperature begins to rise, and if it eventually passes that critical point, it has to reduce the clock speed and lower the operating voltage from all the other cores to bring the temperature back down. So it is basically like a sine wave pattern. However, now it is at a higher level, so with throttling there is a consistent up and down motion, but here further up the scale there is a nice steady flat line. That is exactly how you should imagine it in your mind. So now we have proc hot 98, which is perfectly fine for now, but let's see how many minutes ago it started. And it is still not actually hot yet. So basically we have 30 gigahertz and 3.5 gigahertz. It's been the same so far, so obviously it's not throttling, and the fan isn't really running much. Quite obviously such extreme stress is very rare in reality, but if you truly desire to, you can certainly achieve that. Although if you happen to have specialized software of that nature, or I can also show it with this hardware info that there's one like this. Now the fan has started up more and more, 90, 96, 97 degrees Celsius. Okay, so with a fan mod like this, you can software set automatic settings so that, say, at 60 or 70 degrees, the fan runs at maximum. This is effective for certain specialized tasks, and then if this setting is active, the temperature will visibly drop even more significantly. Therefore, it is essential that the proc hot indicator disappears entirely from the monitor. Now we'll nicely overwrite it. How often should it intervene? Let's make it a full 20 milliseconds, and then observe exactly how much further it lowers the temperature even under these conditions. We're at the absolute maximum load capacity now. Yes, so it's cooling down more and more, and the stress test has been running for a while. Consequently, it would be completely impossible to accomplish this goal while using turbo boost technology and a 45 watt TDP. So, plus, this is a stress test that the laptop will probably never experience in its life, besides the fact that I'm doing it now. So I think this is a good example of why it's worth it. On the other hand, I really do think we're extending the laptop's overall lifespan this way, even though it's not, well, it's not exactly that young anymore, but yeah. And if you take a very close look at how incredibly quickly the internal temperature drops, damn, it's almost 20 degrees instantly. That's very good. So our cooling system is performing very well indeed. I think you can safely set this specific profile to be used automatically every time Windows starts up, and that's it. It really works quite well and should keep things stable. So this can go right onto the auto control profile settings, set to start minimized automatically, and that is practically all that is required for this step. We just add it to the Windows startup folder for automatic execution, and then we are completely finished. So now this is saved. The values are set. That's it. One additional thing that I really wanted to show you here is that if you want to keep these settings, performing a full BIOS update on your system might not necessarily completely wipe those specific settings, because after all, modern systems don't actually rely on traditional CMOS storage anymore. For now, only the clock is stored at that CMOS level. Everything else is already in the physical chip. So I'll restart the machine and show you exactly what to disable in the BIOS so the operating system doesn't end up overwriting it with a possible BIOS update. On a Dell, you can enter the BIOS by pressing F2. This is the usual method on most Dell computers. With a little bit of tapping like this. And then once we have entered the system BIOS, you will find a specific option called Security. And under that Security tab, look for UEFI Capsule firmware updates. So this basically means that Windows or maybe Linux like Ubuntu is capable of putting a so-called newer BIOS update into this capsule. And then as soon as the manufacturer releases a new update, it overwrites it. Personally, I prefer to oversee the BIOS updates myself. Obviously, it's called UEFI now, not BIOS. So apply, we save it, and then exit. Then from now on, the system won't overwrite itself. So that's all for today's video. I hope I managed to share something useful with this. It might sound a bit complicated, but I really made a sincere effort to go into as much detail as I could, to be as clear as possible. Quite obviously, I think everyone has clearly understood the point that it's beneficial to consider reducing the processor voltage, because thermal throttling is not merely a frustrating enemy for those of us who want to work, but for the laptop itself too, as it can substantially shorten its overall lifespan. Especially with performance-based processors in laptops that are quite powerful, the H-series processors, i7, i9. Unfortunately, this is all part of the deal with those. So next time I'll be back with a brand new and very interesting video, but it might be a massive, intensive programming and hardware development project. But I won't spoil the details of the surprise just yet. So now my laptop temperature isn't quite as hot as Death Valley anymore, so that is good for the time being. Actually, I'm going there next year, but let's keep that a secret for now. Even though I just said it. So the second season is coming soon, or next year, hopefully. So thank you for being with me. You can find the description on my GitHub or under the video, under the YouTube video. If you liked the video, you know what to do, and if you didn't, do it anyway. If you haven't subscribed yet and you're interested in future content, I'd appreciate it. And be good. Bye.